Welcome to the latest Ticker TV interview. I'm Donald Leggatt. I'm joined by George Bennett, CEO at London main market listed Rainbow Rare Earths, or RBW. Rainbow have been developing a low-cost, high-margin project which extracts rare earth from phosphate gypsum feedstock in South Africa, with a definitive feasibility study due to be published next year. In the meantime, the company had pivoted from CIC extraction to SX. So, plenty to talk about this morning, George. Rainbow have had a very busy year and the share price has reflected that nicely. It's had a nice bounce. So tell us, what do you make of that?
Well, thank you, Donald. It has been a very busy year for Rainbow, and in a positive way, of course. We've seen massive changes in the market this year that I always indicated were there in previous interviews you've had with me, which is that rare earths are extremely important to the West and globally for all modern tech. And with the Chinese restrictions imposed on rare earths and permanent magnets at one point earlier this year due to the tariff war with the US, suddenly the whole West has waken up even more than what they were awake to this critical strategic source of metal that goes into all modern technology. And as I said, that's been highlighted by Donald Trump and America throwing a lot of money at building out the strategic supply chain to be independent from China. And we've seen Europe also starting to act on this now, not as aggressively as America, but they are starting to act in a very positive way. And we saw this culminating with the Department of Defense or Department of War in America doing a deal with NdPr Materials to guarantee them a floor price of $110 per kg for neodymium and praseodymium, two key rare earth elements that go into what's known as permanent magnets. That benchmark floor price set the stage for various offtake discussions that we're having globally at the moment with various offtakers. And we also saw the Chinese, who had been suppressing the price of neodymium, praseodymium in the global market to try and prevent development companies coming on stream like Rainbow. And we've seen that with them realizing that they can't keep the price down. Even the price of China of neodymium, praseodymium has now risen strongly since they deal with NdPr Materials. And we see the price in China circa $95 to $98 a kg. So very similar to the floor price offered by the DOD to NdPr Materials.
Crikey. So I was going to say that the West, and in particular Europe, are paying more for the various rare earths, which they of course desperately need. And I was going to say, are these high prices stable and here to stay? But it seems the Chinese prices are coming up to join the high prices in Europe.
That's correct. We've seen the Chinese price increase significantly over the past few months, as I mentioned, not quite at that benchmark price yet, but getting closer to it. And then there's various other key rare earth elements. Dysprosium and terbium are two of the other key rare earths that go into permanent magnets like neodymium and praseodymium. And the prices of Dy and Tb, as they're known, are trading in the last 6 months, 7 months, 2 to 3 times higher than the price they're trading in China. So we've also seen a bifurcation of pricing, which we anticipated happening, and this is happening. I mean, I spoke on very public forums at rare earth conferences last year, and I said that we had to get a floor price in rare earths to support the new development projects. And I'm glad I've been vindicated in that we've seen what's happened with the Department of War and NdPr Materials. And since then, you've had the Australian government announce that they're going to entertain floor prices for critical minerals. And you've also had the European Union also now announce that they are looking at also supporting floor prices for certain critical minerals. And so this has been a very, very good boon for the market and all rare earth development companies, not only Rainbow. It's been good for the market as a whole, and it's something that I was advocating for a while before it happened.
Now, the plan is to develop both NdPr oxide and SEG plus mixed rare earth carbonate products from Phalaborwa, and it seems as though this is a very appropriate time to be doing this. And you've slightly tweaked your strategy to cover these, wider basket of rare earths. Yes,
this is correct. I mean, initially we were looking at using continuous ion chromatography as the final separation circuit, which is a technology that was bandied about and it's used in other industries, but it's never ever been used in the rare earth space to date. So we thought this was interesting. We went down that road, and what we needed to confirm was that we would get the separation of our 4 rare earth elements that we were chasing at that stage, which is neodymium, praseodymium, dysprosium, and terbium, and we would get 99.5% plus purity. Unfortunately, we couldn't quite get there in the timeline we were looking at because this development was taking longer than anticipated, and with this race to get development projects into production, because the West desperately needs independent source of rare earths, we decided to relook at solvent extraction. Now, we knew about solvent extraction as a technical team at Rainbow. As a team, we've designed and built numerous uranium plants and copper plants, and these uranium and copper plants, the uranium plants use continuous ion exchange, and they also use solvent extraction. Copper plants use solvent extraction. We've also, as a team, designed and built a very successful zinc mine known as Scorpion Zinc in South Africa. And once again, solvent extraction is used in that circuit. So it was a technology well known to the Rainbow team, but we just thought there might be something better, because normally solvent extraction circuits are very large, very capital intensive, and obviously that adds to your operating cost. And that's why we looked at an alternative. But having successfully incorporated continuous ion exchange into our impurity rejection circuit at Rainbow, which is all rare earths have a lot of impurities in them, which you need to reject if you want to get to that high purity level of 99.5% plus purity. That speaks for itself. You've only got less than 0.5% of impurity then. So you need to focus on impurity rejection before you go into that final downstream separation circuit. And what we successfully did is that we incorporated, as I said, continuous ion exchange. So we reduced our volumetric flow of our pregnant leach solution going into that circuit from 340 cubes an hour. It goes into that continuous ion exchange. We see quite heavy impurity rejection at that stage. Then we do another 3 stages of final impurity rejection using precipitation processes. And those 3 precipitation steps lead us to a volumetric flow of about 6 to 7 cubes an hour, now feeding the final separation circuit. So I'm sure your investors and the audience can understand, from going from 340 cubes an hour volumetric flow to 7 cubes an hour, that massive reduction meant that our downstream circuit now was going to be far, far smaller than originally anticipated, because normally you would have taken that pregnant leach solution and you would have fed all 340 cubes into a solvent extraction circuit. But because we've incorporated CIX successfully with our experience, we've reduced that flow. And now, instead of having, a normal solvent extraction circuit that you'll see with Chinese rare earth plants and certain rare earth plants in the West, I don't want to name them, but they're 1,500, 2,000, what they call mixer settlers. By Rainbow going solvent extraction with the small volumetric flow, we're only going to have 75 mixer settlers in total. As you can see, mathematically, that's a massive, massive reduction.
So your clever combination of IP, if you like, a little bit of CIC, a little bit of SX, it makes it very economic. So if you were to talk us through the headline economics, that would be very helpful, George.
Yeah, so as Donald, just to clear up, not CIC, it's just continuous ion exchange, CIX, and solvent extraction.
Oh, CIX, apologies.
Yeah, and I'll take you through that in just one second. I just want to, and that final solvent extraction circuit has been designed for Rainbow by ANSTO, and I'll talk about ANSTO in a second. In terms of what we realize is that by going solvent extraction, we're now only going to produce 2 products. We're going to do separated neodymium praseodymium to 99.5% plus purity, which means you get 100% payability on those 2 elements. And then we're going to produce what's known as the SEG plus group, which is all the balance of the rare earths, and importantly, it's your heavies. So it's your dysprosium, your terbium, your samarium, your europium, and your gadolinium, and also yttrium. Now, by looking at our earth basket in the SEG plus group, we realize we now have a lot of value in those other rare earths that we weren't targeting before by focusing on continuous ion exchange. Continuous ion chromatography. By going SX, we're now capturing all those rare earths in our SEG plus group. Even though we don't get 100% payability, a mixed rare earth oxide, we will get circa 70% payability. We've used in our numbers. I've been often higher than that, but being conservative for our numbers at 70% payability and using mid-European pricing for those elements in our basket of SEG plus. Our revenue for that basket is now $160 million. And if we looked at the revenue for dysprosium and terbium separated and 100% payability, our revenue would only have been $80 million. So basically, for that basket, our revenue's gone up by $80 million and our EBITDA margin of circa 70 to 75%. I think your audience can work out that's a significant improvement to our bottom line.
So the economics are looking rosy.
Very good. Thank you. Very, very rosy.
Very good. You mentioned ANSTO. Now, I'm not familiar with ANSTO, and last time I heard you were going to do the pilot plant in America. So why the pivot away from America? Why ANSTO and the Australian pilot plant? Tell me all.
Well, in America, we did have a pilot plant, and that was doing the continuous ion exchange, continuous ion chromatography. As I said, we got results in America, but we didn't get the results we wanted in terms of final separation and final purity levels. So we dismantled that pilot plant in Florida. We brought it back to South Africa. We built our own laboratory to do our in-house test work and development of the final stages of our process, and that's been very successful. By incorporating our own laboratory here, in South Africa, we were able to look at optimizing that front-end circuit, which produces the pregnant leach solution, and then the continuous ion exchange volumetric flow down to our final precipitation stages from purity rejection. And that was all achieved in our laboratory in South Africa at a very low cost, but more importantly, at a massive quick turnaround time. By using laboratories in America and Canada, you're waiting 2 to 3 weeks for results to come back from a test you do. Whereas in South Africa, in our own lab, we were waiting a matter of hours. So we were able to run far more tests at about an eighth to a tenth of the cost of using outside laboratories. So in a very low cost environment with a massively quick turnaround time, we're able to move our development far quicker forward. And that's why we ended up with massive success in our continuous ion exchange circuit and precipitation stages, and which led us down to the SX route. Now, ANSTO, the Australian Nuclear Science and Technology Organisation, they're probably the global leaders in the West Circular in solvent extraction regarding rare earths. They've designed and developed most of the solvent extraction circuits for most rare earth projects in development in the world today, including people like Lines in Australia, and I think they've worked with Mountain Pass in America. So they are basically the gold standard for solvent extraction for rare earths. And we've gone with ANSTO, and ANSTO have confirmed that they've already given us the pre-feasibility level of design. That's where I say we've only got 75 mixer settlers in our circuit, and we are going to produce a 99.7% purity SEG plus group and a 99.9% purity NdPr separated oxide. So this has been confirmed by ANSTO, and we now are running another pilot in South Africa to produce enough material just to do a final piloting of the SX circuit in Australia. It'll only take about 4 weeks at final piloting. It will take place next year, but that's just to confirm the parameters of our waste streams, and also to produce product for marketing and for independent verification for third-party due diligence, due to the fact that we'll be having about 2/3 of debt in this project, and we know the project finance banks would like independent validation of this and third-party sign-off. So that's all it's for. But basically, all the risk is now taken out of that final separation circuit, which I announced about a month ago now, I think it was.
And you're at the stage of having offtake agreement discussions, are you, with the pilot plant, the content being produced by the pilot plants?
Yeah, look, we already know what the makeup of our products are in terms of the NdPr, the purity of it. It's been confirmed by ANSTO and the pre-fees, and we know the makeup of our SEG Plus group. The pilot plant's just going to be the independent sign-off, and our off-takers can actually have physical sample. But in the meantime, we've been approached. Well, it started many months ago now. As long as 6 months ago, we saw an increased number of inquiries into Rainbow, where people realized our project was the real project, and we were going to go into construction and production. Is that we've seen offtake inquiries from Japanese off-takers, from South Korean off-takers, numerous European off-takers, as well as US off-takers. So we're in a very, very good space. And when we announced yttrium as one of our key elements in our ECG Plus group, yttrium was subject to specific restrictions by China earlier this year. The price of yttrium has gone up between 1,500 and 4,000% in Europe this year, because yttrium is so critical for aerospace and for defense. And the fact that we announced that we will have circa 130 tons of yttrium in our ECG Plus group, within a week, I had direct calls from some very, very senior defense contractors in the US asking to go into yttrium offtake negotiations with Rainbow, as well as offering us a floor price. So it's been very, very positive for Rainbow, all these developments. And it's definitely been we made the right call in doing what we did.
Okay, you've been quite meticulous in your processes, and you very, very carefully built a development process and now have your own IP. If you could briefly explain to us why having your own IP is such an important thing.
I mean, it obviously puts us at, well, I can say it, even though we're a small company, we're the global leader in this. So we've had numerous approaches by other potential parties who have phosphate gypsum with some rare earth elements in it, and they've approached Rainbow to look at being either a technology partner or development partner. So that profile that we've created around Rainbow has been very positive. It also led us to being able to do a deal with Mosaic in Brazil. Mosaic are a global fertilizer business listed in New York. They're about a $15 billion market cap business, and they have a phosphate gypsum stack in Brazil, and more importantly, it's a live phosphate gypsum stack. In other words, it's an ongoing phosphoric acid plant. The gypsum in Phalaborwa was the result of mining hard rock, phosphate rock, concentrating in the slurry, feeding it into a phosphoric acid plant to produce phosphoric acid for the fertilizer industry, and that creates a gypsum waste residue. The rares that were in the hard rock phosphate weren't economic to mine for the rares alone, but due to the concentration process of the phosphate slurry and then going through the phosphoric acid production process, the rares now sit in the phosphate gypsum at a much higher grade, and importantly, at an economic grade. So that's important, because a lot of rare earth projects suffer from economic grades, and that's why they battle to get into development. And at Uberaba in Brazil, it's almost the identical process used by Sasol in South Africa originally, and more importantly, their stack is the live stack. So it gets fresh phosphate gypsum every single year onto it, circa 4.5 million tons per year go onto that stack. And the project feeding that phosphoric acid production facility in Brazil has got a life of over 40 years. So we have a very high grade, long life project in Brazil, which is very important for Rainbow. And that project in Brazil, we are completing our initial economic assessment on it, which we'll be announcing once Mosaic have reviewed it. And basically, we know it bodes very well, because the economics on that project look very, very good as well. Similar to Phalaborwa, but much longer life and a higher grade project.
And when can we expect that, George?
As I said, in the new year, we'll be announcing the results of that economic assessment.
Oh, that's very exciting. So quite soon.
Yeah, quite soon.
Oh, fantastic. Okay, no, that's good to know. And let's talk Phalaborwa and definitive feasibility study. When does that DFS get published? And what are the key highlights likely to be? You've been developing a lot of these things over time, so presumably you know quite a few of the numbers already.
Yes. Once again, as you mentioned, the RP is very critical. So we've developed this RP in-house. I mean, extracting rares from phosphate gypsum has been the subject of many academic papers over the years. I mean, for 40 years, people have been looking at this, and there's lots of academic papers, but none of them were able to do it in an economic fashion. Rainbow's team have developed the RP to do it economically, and that's a key differentiator between Rainbow and all these academics and sort of sort of university laboratories that looked at extracting rare earths from phosphate gypsum. So we've done it in a very economic and commercial manner. Going forward, as I said, we are looking to complete our definitive feasibility study in the middle of next year, and that's going to lead us into production in 2020, construction in 2027, and production in 2028.
Okay, and my final question to George: why should all the investors watching this, why should they have you on their watch list?
Well, we are a project that is being confirmed independently as probably the highest margin rare earth project in development today. And with that, as I said, it's public. EBITDA margin circa 75%, which I don't think you see in many projects around the world. And then we also at the lowest end of the cost curve, which is very important. So even when rare earth prices were under pressure at $60 a kg for NdPr, and remember they're close to $100 a kg right now, if we were in production at $60 a kg for NdPr with our dysprosium and terbium credit, Rainbow still would have made circa $63 million of EBITDA per annum. There's no rare earth project in the world that could do that at those prices. So at these higher prices, it bodes very, very, very well for Rainbow's economics. And the SEG Plus, as I said, at mid-European pricing, adds $80 million to our revenue that we weren't forecasting just because we've gotten this SX rig with an SEG Plus product that we're going to produce. So I think it's very positive for Rainbow. Thank you.
George Bennett, CEO at Rainbow Rare Earths, thank you very much indeed for joining us from a rainy London today rather than a sunny Johannesburg. But thank you very much for sparing the time. It's always a pleasure to dive into Rainbow and find out what you're up to. Thank you, George Bennett. Thank you.
Pleasure. Thank you for having me.